Hi there, today we're going to look at an MA-1629 soundboard out of a Gottlieb System 3 machine, specifically a Surf and Safari. When I got this board it wasn't functioning and was asked to take a look at it, and since there's not a lot of information on repairing these soundboards and there's a lot of talk online about repairing these soundboards, I figured we'd make this video. This soundboard was used in two different forms, as an MA-886 in late System 80B machines, and then as a MA-1629 in System 3 machines. It's a pretty ubiquitous soundboard. The board has two microprocessors, two 6502s. Each 6502 has its own ROM and RAM, and this is the Y section of the board. And over here, this is the D section of the board. The Y section of the board starts the D section of the board when the machine is powered up. It also controls the S4 expansion socket that's here, that usually has an auxiliary soundboard connected to it. And the auxiliary soundboard is responsible for generating the background sounds and the callouts. So the Y section gets a lot of use on this board. And the D section is responsible for the inputs from the CPU, so it processes all the inputs and makes sure that the correct sounds and what have you are played by either what's generated on the board for the sound effects or off this board on the auxiliary soundboard for the callouts and the background sounds. There's two connectors on this board, the P1 and the P2 connector. The P1 connector is the input connector, so all the inputs from the CPU come in here, which are pins 1, 2, 3, 5, 6, 7, 8, and 9. Pin 10 is a reset pin. This board, when it's powered on, gets reset by the CPU. It doesn't reset on its own, but it can be reset on its own with the reset switch that's on the board right here. The P2 connector has all the voltages in, which are plus 5, plus 12, and minus 12 volts on this half of the connector. And then these two pins on the end are the audio out and the analog ground for the actual sounds that are generated on this board, which then get sent to the auxiliary soundboard and mixed together, which get output to the speakers. This board has two op amps on it, one at B1 and one at A5. They get multiplexed through this DAC at E2, and the B1 is the op amp that goes out to the analog out. This board was originally installed in the Gladiators, and there was a label on it that you'll see later in this video indicating that. But it came out of a Surf and Safari not working. When I got the board, the Y-ROM had a pin bent and it wasn't installed right in the socket, so there was no way that this board would be able to boot as a result of that. The contents of the ROM itself were fine, and they were checked with a ROM burner, and the contents of the DROM were fine as well. So with this board not working, the best way to evaluate it is by using a test ROM that was developed by Marco Albus from the Netherlands. He has a 2-ROM set that goes into the DROM and the Y-ROM sockets, and this board can be pretty well tested by his ROMs and just a simple 5-volt power supply. So if you have a 5-volt power supply and can burn his ROMs, and then the other thing that you need in order to test this is an LED that has a couple of gripper wires hooked up to it, and one goes to one of the address lines. The ground wire goes to the address line on one of the CPUs, and this goes to your 5 volts, and there's a 1000 ohm resistor in here so as not to overload the address line when the test is running. So between this LED, the onboard LED, and the 2 test ROMs and 5 volts, you can pretty much find out what's wrong with this board pretty easily. So the next part of this video will show you, we'll have everything hooked up, and we'll show you how to run the tests, and we'll show you what was wrong with this board. And if you look carefully at this part of the video, you can probably see what the problem was. So here we go, next part. Okay, we're back. We've now installed the test ROMs, the D and the Y test ROMs, into the board. And we have this little LED that on one end is hooked up to pin 17 of the T3 processor, which is for the Y ROM, and the other end is hooked up to 5 volts. And we need this to monitor what the test program is doing so that we know if we see an error. So we have the ROMs and this little LED, and then we have power. And so we're ready to power this up and see what this board's going to do. I'm actually going to shut the light because it'll be a little bit easier to see the LEDs. Now with Marco's test program, it's actually pretty nice. The first thing that happens is when you power it on, when you power this on the bench like this, you'll see the LEDs will start flashing, and that's because there's no actual reset on this board. You can see there are the LEDs. So the program is just randomly executing code, and there needs to be a reset in order to start the actual tests. And the way that you do that is with the reset button that's on the board here. This is also useful if in the machine the board doesn't seem to start properly, and if you press that, the board starts, then it shows that it's not getting a reset signal from the CPU. But when I press the reset button, what will happen is we'll get a flash, and then we'll get a dim flash, and that's starting the memory test. So if I do that now, you'll see, here we go. There's a flash, and there's like a couple of other flashes, and I don't know why it's doing that. And the onboard LED was flashing as well. I'm not sure why it's doing that either, but you see now it's actually hung on this dim flash. This is in the middle of the memory test. And what should happen is there should be another flash after this, and then this LED flashes again. And that would tell us that this memory chip is okay. But because of the fact that it's stopped here, the test is halted, that tells us that this memory chip is bad right here. The one that's associated in the Y ROM circuit, it's the one at H3. Because if this had tested well, if it had passed, then this LED would then start rhythmically flashing. It would just flash waiting for the input test to be done. And it can't be done now because it's halted. So if I and you need to repeat this test too for both processors and both circuits on this board. So now what I'm going to do is I'm going to take, I've taken the power off the board, and I'm going to take the clip off of pin 17 on this 6502, and I'm going to hook it to pin 17 on this 6502. Sorry for bumping the camera there. Okay. So now we're going to power it up again. And again, when you first power it up, the flashing that you see doesn't really mean anything. Oh, I thought I had it on. Guess I didn't. Okay. So now I'm going to power the board up. And see, there's the flashing. And you see the flashing slightly different for this circuit because it hasn't been reset yet. So now if I press the reset button, we'll start the test on this side of the board. And you'll see you get a flash, and then you get a dim flash, and then you get another flash. And then now what's happening is this is flashing continuously, which means that this section of the board has passed and this RAM has tested good, and so this section is waiting for inputs to happen. So the problem with this board is the RAM at location H3, and that RAM needs to be swapped out before we can do any further testing of the input circuitry on this board. And I'm going to repeat this one more time so you can see what it should look like normally. So I powered it off, and then I'm going to power it back on again. And there it is flashing. And if I press the reset button, the first flash, by the way, tells you that the reset and that the CPU and the ROM is being read and the program is running. So it tells you that this whole part here is actually working properly. So I press the button, and there's a flash and a brief flash and then another flash, and then now it goes into its normal flashing. So that tells you that this side of the board is working okay. So now what we'll do is we'll swap out this RAM chip here at H3, and then we'll come back and run the tests again on that side and go from there. Okay, we're back, and we've done a little bit of work. My desoldering iron needed some maintenance, so I took the opportunity while I was doing that to put this board in the dishwasher and clean this. Got it nice and clean, nice and sparkly. And then after that we removed the RAM chip at H3 and we put in a socket and a new chip. Here's the old one. You can see I cut it out. When Gottlieb assembled these boards, these legs on the chips were actually bent underneath to hold them while they were soldered. It makes them very difficult to get these parts off the board without doing damage all at once. So the easiest thing to do is simply to cut it off and then desolder each pin one by one, and then because these are very fine traces, very fine through holes, it's very easy to damage this board if you're not careful. So so we have a new RAM chip and a socket. The board's nice and clean. We have our test LED hooked up and our test ROMs back installed, and we're hooked up to power, and we're about to power this up and see what happens. I'm going to shut this light so it'll be a little bit easier to see the LEDs, and then we're going to apply power to the board. And when we do, we see the LEDs are flashing. So now we have to reset the board in order to start the test. And we do that by pressing the reset button that's right here on the board. And when we do that, what will happen is it'll stop flashing, and then we'll see this LED will flash, and then should have a dim flash, which it hung on earlier, which is indicative that the memory has failed. And then after that it should flash along with the onboard LED, and then you'll get another onboard LED flash, and then this will start flashing slowly. So here we press the button and we get a flash, dim flash, and then another flash, and then this also gets a brief flash before this one flashes again, and now you see this one is flashing slowly. This is not what it was doing before, and this is indicative that this section of the board is now running, whereas before it hung up on that dim flash, which meant that this RAM chip was bad. I'm going to press the reset button again so you can see what that looks like. So there we go. We get a flash, dim, quick flash, and then another flash, and another quick flash, a second flash on the CPU, and now its test is running. The second flash on the CPU LED is for the non-maskable interrupt circuitry on the board, and the test generates an NMI to itself in this section, and then if that is a successful test, this LED flashes again, and now the board is in the I/O test. And just to confirm, if we touch this to the other address line, you'll see that that's flashing as well, which means that this section is running. But I can press the reset button again so we can see that it goes through the same set of tests. Ready? Press the button, flash, brief flash, another flash with that going on, a second flash there, and now this is flashing. So now we know the D section is working completely and the Y section is working completely. So we have what we need in order to continue our testing. So now these parts of the board are good. So the next thing you test are the inputs, which are down here on the board on the P1 connector. These are the S inputs, and if you've ever run a sound test on a System 3, especially on the DMD, and it gives you the different tones, basically what it's doing is it's testing each one of these lines, each one of these pins on the soundboard. So for us to do that on the bench with Marco's test, what you do is you take, I have this yellow cable that is hooked to ground, and what you do is you short it to each one of the pins, 1 through 3 and then 5 through 9. And every time you do that, both the onboard LED and the test LED will blink twice. And if it blinks twice, then you know that that input line is working correctly. So let's touch the first one, pin 1, and we get 2 flashes. So now I'm going to touch pin 2, and there were 2 flashes again. Now I touch pin 3, 2 flashes again. Pin 5, did I get 2 flashes there? Yep, 2 flashes, pin 5. Pin 6, 2 flashes. Pin 7, 2 flashes. Pin 8, 2 flashes, and then lastly pin 9, 2 flashes. So that tells us that all of the inputs lines and all of excuse me, all of the latches are working correctly for the inputs. If you don't get the second flash when you test any one of these lines, you have to check either A2, which is this chip right here, the 7430, or you have to check A4, which is, this is a 74LS74. If you don't get that. There's also an exception for these boards if you don't have a jumper at JP8 down here, and that could be problematic for S16 if you're testing that particular input, but I'm not going to go into that for this video. So now we've tested the inputs, so we know the inputs are working, we know this is all working. So now the last thing we want to check is we want to check the S4 socket, which interfaces to the auxiliary soundboard, and that's usually done by some type of ribbon cable, as you see here. That's what the ribbon cable looks like, and here's the auxiliary soundboard that this hooks up to. This is an MA-1770, and before we hook that up to test it, what we want to do is we want to look at a few of the signals on the S4 socket. And I have my probe scope here, and basically what you want to do is you want to look at pins 11, 12, 13, 14, and 15. And if let's see if I can get this on the video. Just a sec. See if I can get this set up. Okay. Now, what will happen is if I move this LED into the frame as well. Oh, no, I disconnected it. Hold on. Let's see if I can hook this back up. Trying to get everything at once. It's a bit of a challenge. So, hold on. We'll get this. So now, I'm going to shut the light again so we can see the LED. So here's the LED, and I'm going to touch to pin 11, and I should be getting, oh, no, I can't, I'm still not in the frame. Still not in the frame. Well, what you would see if with your logic probe or your oscilloscope on pins 11, 12, and 15 is the probe, the scope, showing you it's strobing in the same way as the LED. So when the LED is on, the logic would go high, and when the LED is off, the logic would go low. And you'll see that on pins 11, 12, and 15. On pins 13 and 14, you'll see a narrow spike, and that may or may not manifest itself on your logic probe. So can I get this? Am I in here? Can I? Nope, I still don't have this in view. What's going on? Let's try. Let's see if I can move this over here. Hard to do this stuff. Can we see it now? In fact, I think I have a problem with my probe scope. There it is. Yeah, so here, so you can see when the LED goes high, the probe scope goes high, and when the LED is on, when it's off, it goes low. So there you know that the signal is actually making it out the socket and would go to the auxiliary soundboard. You want to do the same thing with pin 12. It goes high, comes low, on, high, off, low. Pin 13, you see a little bit of spikiness there at the top. That's what you should see. Same with pin 14. You see those spikes. And then in pin 15, you see, am I touching it? I don't know if I'm touching it. Oh, there it is. Oh, no. No, I think I have a lead. There it is. No, I think I have a lead problem on my probe scope. Nope, there it is. On, high, off, on high, off. Okay, that was a little tricky, but you get the idea. So doing that, you now know that your signals are making it out the S4 socket for your auxiliary soundboard. So you know that that's good. And okay, so you want to shotgun this board. Well, here's you know, you wouldn't be the first person to do it, and you certainly won't be the last person to do it. And there's a logical sequence to shotgunning this board that you should perform to try to minimize the work you'd have to do. Really should use the test ROM. It just makes it so much easier and gets right to the problem. But if you don't want to and you just want a shotgun, this is what I would do. First thing I would do is I would verify all the voltages that come into the A6 P2 connector. Your +5, your +12, and your -12 volts. Mainly your +5, because the +5 drives the logic, and that'll get the board blinking and you'll know it's booting. But also you should verify all 3 voltages that are coming into this board. Because if you don't have the right voltage, the board won't boot. And then you know the problem isn't on this board, the problem's somewhere else. If you verify your voltages and they're all okay, then the next thing I would do is I would start with the ROMs. And I would swap both ROMs out, both the Y-ROM and the D-ROM. And there are a couple of options for the ROMs. You can get them either from Steve Young at Pinball Resource, or you can get them from John's Jukes in Canada. Steve Young will probably get 30 or 40 bucks for the pair of ROMs, which is a lot of money. I don't know what John's Jukes is going to get for the ROMs, but you know, if you're getting them shipped from Canada to someplace else in the world that's not Canada, it's not going to be cheap. At that rate, you might want to think about investing in a ROM burner, and there are ways for you to get the images of the ROMs and verify the ROMs without you spending a lot more than the 40 bucks plus shipping that you would have to spend in order to verify the ROMs. But I would do the ROMs first because they're socketed, they're easy to test, and if the ROMs are bad, then you know the board isn't going to boot. So you need to make sure that the ROMs are good. So if you check the ROMs and the ROMs are good, then the next thing I would do after that, if I'm going to shotgun the board, is I would swap out the RAM at H3. This RAM fails more often than pretty much any other component on this board, and the chances are if the ROMs are good, this is what's going to be bad and it's going to need to be swapped out. So I would pull this socket and put a new RAM chip in. If after you swap this RAM chip it still doesn't boot, then I would go for the RAM chip at H2 and then swap this one out and see if the board boots. If after you do that and swap these 2 RAMs and it still doesn't boot, then I would go for the microprocessor at T3, and that may very well have failed. It doesn't happen often, but it's possible that you have a bad microprocessor. So you'd have to get a new 6502 and then swap that out. And if after you do that it still doesn't boot, then I would go to the microprocessor at N1. Basically, you should always start with the Y section and then the D section. So ROMs, Y, D, Y, D. The chances are by that point the board should boot. You would have likely gotten the bad component, you know, at least in terms of the board booting. And this also, of course, assumes that you don't mess up the solder job, break any traces or through holes or anything else like that. If the board is booting but it's not functioning correctly, you could have a problem on the input sides, and that will usually manifest itself in the sound test, where you run the sound test and you're checking each one of the S lines. So if you have a problem with the right sounds playing, I would swap the input chips out. I'd first go with the A2 chip, the 7430, and then I would, if that doesn't solve it, then I'd go with the A4 chip, the 74LS74. And the chances are that if you have an input problem, swapping one of those two out will solve it. If you're not getting any sound out of the board, the voltages are good and the board's booting and the light's blinking, you're not getting any sound, you could have a problem with the op amp, and that would require you to swap out first B1, and then if that doesn't solve the problem, I'd swap out A5 and then see if swapping one of these two will actually solve the problem. So you might have another logic failure on the board in one of these other chips, but by that point there's not really that much left that you have to worry about in terms of something not working, and you by now shotgun most of the board and everything is good. So that's your shotgun guide to fixing this board. As I said, I wouldn't recommend doing it. These boards, you can't get any more. You damage the board, it needs to be fixed. Who knows if someone would want to fix it. You know, I mentioned earlier in the video how these components are attached, and you can sort of see right here, you can see how these pins are bent over. So these are the pins for the ROM socket, and you can see how they're bent over. And it's the same thing if I look at the DRAM. You can see right here, see these pins, see how they're bent over. Replacing these pins, you have to be really careful. It's very difficult to get the solder out from underneath the bent pin and release this chip without doing damage to these through holes. So you don't really want to do any damage when you're doing that. So that's why shotgunning is ill-advised, because you don't want to be changing out parts that aren't bad. But anyway, there you go. Thanks for watching, and good luck.